Alright, let's continue with partial fractions and look at this example. Okay, this is an example of improper fraction where you have 4x to the power of cube over with 2x to the power of 2. Right, so this is bigger than this one. Let's discuss the solution. Alright, so as we have discussed before, to conduct partial fraction, the first rule is that the form of fraction here should be a proper fraction, meaning that this should be lower than this, the power. Right, so because of it is improper, we'll need to make it proper first by conducting long division. Now, I believe that most of you guys are already familiar on how to conduct a long division method in division, right? It is that maybe you'll need to look out on how to do it for polynomials function, right? So for our case, it is 4x to the power of 3 plus 10x plus 4 over 2x to the power of 2 plus x. So this over this, right? So let's see how do they do it. We look at it one by one. Okay. First, they try to solve for 4x to the power of 3. So how to get 4x to the power of 3? Right? We'll need to multiply 2x, right, to this. So 2x will give times this will give you 4x to the power of 3 together with plus 4x squared, 2x squared, sorry. That is how they get this. And then you're going to subtract. Okay, one thing that I want you to be clear with, okay, in polynomial, right, the idea of arrangement in power apply. So we'll start with 4x to the power of 3. The next should be to the power of 2, and after that to the power of 1. However, if you look at this, we don't have to the power of 2. So it is wise, right, when you conducting long division, right, to leave a space for x to the power of 2. And because later you need to consider that in your calculation. Let's say your polynomial function is 4x to the power of 5 and then plus 10x like this. Still, you will need to leave a space for 4x to the power of 4, 4x to the power of 3, 4x to the power of 2, then 10x around this area. You need to leave a space because later they will appear down here like this. Okay, so let's proceed. 4x to the power of 3 minus 4x to the power of 3, you get 0. 10x, then you have you don't have x to the power of 2, so we just say 0 minus 2x to the power of 2 will give you negative 2x to the power of 2. And then we'll take down 10x, so we have negative 2x squared plus 10x. So how to get negative 2x squared? Of course, we'll need to times this with negative 1. Negative 1 times it will give you negative 2x squared. Right? Together with negative 1 times x will give you negative x. So subtract it, you will get 0 here. So 10x minus x, you will get 10x minus negative x, or 10x plus x, you will get 11x. So let's pull down 4. Now, as you can see, this compared to this polynomial function has a lower order compared to this. So this will be the end. We cannot really proceed anymore. Alright, so the answer the result of long division for this function will be 2x minus 1 plus with 11x plus 4 over 2x squared plus x. Alright, this is the long division, the result of long division. Okay, so meaning that now they have two functions out of long division. Right? So instead of just one function, it has become two functions. However, for 2x minus 1, it will be easy for us to integrate, right? We will get x squared. Right? X squared minus, we'll see later. However, this can be just being integrated using our properties. Okay, as for this one, we are going to need to apply the partial fraction. So you have here x and 2x plus 1. Right? This is linear and this is linear. So without any exponent. So linear factor rule applied. So we have a over x plus b over 2x plus 1. Okay? So after we have this, it will be the same thing again, right? We are going to figure out the a and b by first multiplying them with the denominator to come up with this, and then play around with x. Now we have two unknown value, a and b, right? Look for a value of x that can eliminate one of the unknown value. For this case, when we put x0, you'll get a4. And then after you have we have solved for one unknown variable, the next thing you'll just put any x value to solve for b. Alright, then substitute the values. And we have the complete partial fraction. We can proceed with the integration to get the answer. That is, but for this question, the one that I want to focus more, that I want to emphasize is on the long division methods. Alright, so let's try to do this exercise, 4.15. Alright, so x squared minus with 4x plus 1, and let's look at the denominator. It is actually x times x squared. You get x to the power of 3. So basically this is a proper function. There is no need to conduct any long division. We can proceed with the partial fraction. So how to conduct partial fraction? Now they have already factorized it for us. And we have here a linear factor, and this is a quadratic factor. So we can apply these two ideas. One will be linear factor and the second one will be the quadratic factor. So this is how you should write it down. We have for linear factor a over x minus 4, and as for the quadratic factor bx plus c over x squared plus 1. Now that we have write it down like this, the next thing to do is to eliminate the denominator by multiplying them with this. Okay, that will leave us with all of the numerators with the multiplication, right? So for a, right, we cancel out the x minus 4, that will leave us with x squared plus 1, and for the quadratic, right, we cancel out the x squared plus 1, that will leave us with x minus 4. Now, when we have reached at this point, the next step will be figuring out the value of a, b, and c. I would advise you to not expand out these functions, because it will be easier for us to figure out what will be the value of a and b and c later. Alright, so we have three unknown value. Let's see what value of x that can be substituted so that later we will able to eliminate 2 out of the 3 unknown value. So you can see for this one, if we substitute with 4, 4 minus 4 equals 0. 0 times this will give B and C 0. So we're able to figure out A. So let's do that. Okay, by substituting x equal to 4, we get A equal to 1 over 17. So just write back the equation with 1 over 17 substituted in it. Now we have 2 unknown value. What will be the x that can be substituted so that later 1 out of these 2 variables will be 0? Obviously, x equal to 0, right? When you substitute x equal to 0, B will be eliminated and you will get the value of C. Alright, so C is equal to negative 4 over 17, right? I have substituted 0 here. Now just write it down and substitute A and C, right? We have to substitute C next. Now we only have one unknown value, so what's left now is just to figure out what, just substitute x with any value. Well, the easiest will be 1, right? And you should get the value of B. So I get B 16 over 17. So up until this point, we have figured out the A, B, and C that we want to look at here. So we should be able to complete our partial fraction function. Right, this one. So this is the partial fraction function. As you can see, we have now have 1, 2, and we can say 3 functions. I will put it like this. Alright. Now the next thing to do is just to integrate it. Right? I have pulled out all of the constant. So the integration of 1 over x minus 4 is ln x minus 4. Right? As for this one, let's look at this one first. 1 over x squared plus 1 is also ln x squared plus 1, the integration. Right? As for this one, as you can see, we can't really solve it directly because we still have 2 functions here. So we'll need to solve it, right? As far as I can see, we can start with substitution, see whether we can integrate this or not. Okay, I have solved it out. So we are using u substitution. Yeah. So u equal to this, right? So it becomes x over u, or x times u to negative 1. And then we should change everything in u terms. So I did get u negative 1 du over 2. So I pull out the constant 1 over 2. 1 over u will be ln u. So ln u substitute it back, we'll get ln x squared plus 1 over 2. Okay, so this is the integration for this one. So just substitute it in. Right, substitute it in. So cancel these 2. I can still simplify it. Right, so this is the final answer. Okay, so for this one can also be changed based on the properties. It is tan inverse, right? Tan inverse. Okay, that is for this question. For the next one, first we'll see that this is x squared over x negative 9. X minus 9 is in improper function. So of course you need to make it proper first, right? By conducting long division. Alright, and the long division gives me this, right? I have the proper function. So shockingly, I don't really need to use partial fraction to solve this, because as you can see, I don't have 2 polynomial functions. It's just one polynomial function as a denominator, and the others is just a constant. So I can just solve this using substitution. Right? So that is for partial fraction. Thank you.